we're actually going to move away from Ruby just for a day or two for this week and go into other things to help us prep us inside of Rails. One of the first things that we'll be jumping into is SQL. And if you can all please, if you plan on following along, a good program that I'll be using is this program here called SQL Electron. I don't know why I posted in a thing, I'm sorry. So go ahead and once you get to the site, go ahead and press this download GUI if you want to follow along. But everything that I'll be doing, I'll be slacking out at the end as well. This is a good tool to check inside of your databases and all that. And there's also some configuration things that we need to do with this program just to get it up and running. So after you download it and allow it inside of your security privacy, you'll get into this screen here and it'll say new, and then that's where we'll start for today. So go ahead and I'll give you a few seconds to talk about that. So
we download the GUI, right?
Correct.
So download GUI.
Yes.
Then it takes me to the releases. Like it doesn't start a download, I don't think.
Yeah, and then with the releases, you want the DMG file. So the latest is 1.30 DMG.
That's the one we download then.
Yeah, this one works as well.
Got it.
Mac, but it's a little bit more slower. So be sure to do the DMG one. And then there's others.
What does DMG stand for?
It's just a program download extension. I actually forgot what it stands for.
Because every time I see it, I feel like it says damaged, and so I'm like,
Yeah, I feel like it's an extension like .zip or .html, .yaml, things like that. So.
I just looked it up. It's disk image.
Oh, that makes actually a lot of sense. Okay.
So I downloaded it.
Yeah, downloaded it, and then it'll tell you to install it, and may ask for you to allow it because it's from a unknown, or allow it inside of your privacy policies, security privacy, things like that. And it should take you to this screen here, but don't do anything once you hit this screen.
So mine just says no result. So just leave it there. It's that same screen, it just says no result on it. Or do I need to?
Totally fine.
Okay, cool.
Yeah, this is what we'll be creating as a class.
Sweet.
Can you just remind me how to allow it? Because it's from an unidentified developer.
So if you go into the Apple icon at the top left, go to System Preferences, and then Security and Privacy. It might be located differently than each machine. I noticed that. So once you go to Security and Privacy, it will take you here. And then around here, that's where you would click to allow it. And you might have to type in your password as well. And then this is the end result. And don't worry if you don't have this yet. Is anyone still waiting for the download? Should be relatively quick. So when you get to this screen, it should be nothing there. Is that correct?
Mm-hmm.
What I want you to do is press add. So go ahead and press add. And then it will take you to this pop-up here. Go ahead and type what you see here. So localhost 5432, and then make sure this is Postgres SQL. And that's it. Everything else would be blank and by the default settings. So click on add, and then fill out these fields, only 4 fields. and then go ahead and press test, and that should give you a good result, and then go ahead and save that once the test is passed.
I think it's a connection error.
Oh, if that's the case, do command space and then do Postgres like that. And make sure that this is started. So it shouldn't say initialize, this should say start.
Okay.
And it's this little elephant up here if it is started.
And I should only have like my name, Postgres, and template 1.
Inside of the Postgres 10.
Yeah, or 12.
Yeah.
Okay.
As long as it's running, it should be good.
It's
And
updating now, so.
it should say test successfully connected. Again, I did command space and then I typed in Postgres to get this little window, and I press start here. Okay, is everyone good?
Wait, how'd you get to that part? Because mine's asking for an update on my Postgres.
Yeah, mine did too.
Yeah, go ahead and update it if it does ask for an update.
It only gives
What if
me
I'm
the
getting a connection error? What if I'm getting a connection error? It's saying database owner does not exist.
Do command space and then type in Postgres, and it should take you to this screen. And then make sure it's started.
Yeah, I got a connection successful, just that I needed to update.
Yeah, me too.
So yeah, be sure to update it if it does ask you to update Postgres.
It's saying the port is already in use.
If you do stop and then start, does that help?
That worked for me.
It's not, the stop button's grayed out for me.
Yeah.
I think you had this issue before.
I think restarting your computer rearranges your ports, but I don't know if you want to restart.
I'll probably help you out during break. There's a certain command that you have to do to stop that port. But whatever I type in this program, just type in like a notes file for now.
Okay.
Yeah.
I thought there was a way to stop it in the terminal. But...
Yeah, there's a certain command. I don't have it on top of my head, unless Harlan knows it on top of his head. Okay.
Should I have all those auth run development and tests or no?
Nope, these are the databases that you will eventually have, essentially.
Good.
That's a good question. Okay, so once you have this, it's okay if you don't. Go ahead and press connect, and it should take you here after you create it and save all those options. And this is as big as I can make this window. But if you need, I can paste it inside of here for you to see as well. So I might be doing that just for usability and for you to see. So let's go into the topic. So today we're actually doing something a little bit different, and that is SQL QL.
Henry, test. Sorry to interrupt you. I see test, cancel, and save. Where do I connect?
Just go ahead and press save for that.
Thank you.
Yep. So what SQL is, it stands for Structural Query Language, and essentially is a type of language that allows you to talk to your databases. And this is mostly on your backend. And when you have a bunch of databases, you need a way to communicate and to interact with your databases. So essentially, if you click on this here, mine will actually have more than yours. But essentially, these little barrel-looking things, these little cylinders, those are each individual databases. So eventually, you'll have a bunch of databases inside of your machine. And there's a lot of ways that you can use SQL There's SQLite, MySQL, Postgres, which is what we're using now. And then there's Oracle and Microsoft SQL. So those are different tools that allows you to have access to the database and also to store all the databases. So just think of Postgres as a place where you store a bunch of databases. There's also other things that doesn't have anything to do with SQL, and that is CouchDB and MongoDB. Those are also databasing languages, but it doesn't use SQL at all. SQL is a lot more well-known, and a lot of people want and need for SQL. So that's why it's much more popular than these ones. Typically, you would see these two if you're just running a full JavaScript application. But you can use these other ones as well. But yeah, the more specific one is PostgreSQL. That's the one that actually connects to your Rails application. And later on, once we jump into Rails, you can see that when we run Rails applications, it actually runs them inside of SQL and then translates it into the Rails language itself. So that's why we're learning a little bit about SQL right now. It's just to see what actually is going on in the database itself, because later on, it all boils down to SQL when we are doing anything database-wise. And just as a quick segue, before we go into these terms, the different data types that you have in SQL are almost the exact same as the ones that we dealt with Ruby. So there's also integers, Booleans, dates, right? They're all the same. Not databases, dates. But there's also, instead of strings, they're called varchar. Those are just characters or a bunch of types of characters. So instead of strings, they're called varchar, which is just a bunch of characters connected. There's also text, which is very similar to a string, but it holds a lot more types of words. So a normal string can only hold, I believe, like close to a couple thousand, and then with text, it can hold even more than that. There's also time and time stamps. Those just are another way to help you with time. So the main difference is just be sure you know between varchar and string, but they're basically the same. But everything else should be very similar. And again, these aren't the only data types. These are just the ones that you'll be seeing the most of. If you actually want to see all of them, this is inside of your Neo. And you can see that there is a bunch of them, right? There's like double precision, JSON, money, polygon, etc. Right? There's a lot of data types. You just need to know which one you'll be using the most. Okay. So now let's just break down some keywords because this will help you further understand what's going on. So when we were talking about a database, we're actually referring to the whole database server itself. So this is what actually holds all of the information inside of a certain application. So each and every one of your application may have one or more databases. So typically there will be a database for each application. So for example, let's say for your grocery store, if it has a database to it, then there will be like a grocery store database with that. And then it's kind of pretty hard to visualize data and databases. So the best way to visualize it is in a table, right? A table with rows and columns. So you can think of an individual table, which is inside of a database, and it has many rows. So these are typically one of your main attributes in a sense. So for example, if you have an application and the application has posts, like Facebook has a bunch of posts, that will be considered a table. And we'll practice a little bit more with that idea. You can think of them as objects if that helps. So individual objects could be its own table. And table has its own rows. So the first actual table is essentially what the table has. And those are the columns, right? Those are the attributes. Every row after that one is called a record. And that is a different types of instances of the table itself. So that means that if you have a Facebook post, those are the different posts that you have on your Facebook wall or something. So that's what a record means, is a individual instance of that table. The columns, that are pretty simple. They are just attributes that a table has. So for example, post has a title, description, author, time, and other attributes that you may have, right? So those are considered columns. Just think of them as attributes describing the table or describing the object. Like if we have a person's table, then the column would be first name, last name, age, address, etc. And each of the rows will be different people. So there will be one row for Bob, one row for Jill, etc. So when we're talking about database planning, we will be using these terms, and you'll begin to see more of this later on.
So like if you had to have users, would it be like that would be your table, and then like the column would be the user names, and the row would be the value of that username and password?
Correct. So yeah, so if you have a users table, then the columns for that table would be username, email, and probably something else, right? Like their nickname or something like that. Or their
And password?
Yeah, and password. And then the rows would be their actual values for those items.
Okay, so table is like the form. Column is what you're calling each one of those fields, and then the row is the value?
Correct.
Okay.
Except for the first row, which is technically the column. And
Okay, yeah.
I can let me give you example here. So imagine this is a table. So the first row is actually all of the column names, right? Because these are the names, aliases, and descriptions. So that first row, that just means that is what the columns are. Every row after that, those are records. Like that.
And are all tables that way? You can't have a column on the left to right. It's got to be top down.
Yes. Well, I guess you can view tables multiple ways. But yeah, most cases rows are left to right and columns are top to bottom. Or yeah, top and then
Okay,
yeah.
cool. Thanks.
Yep. And these are certain attributes that you can have. Again, this will make sense a lot more later when we actually use them. So there's something called primary key. And what the primary key is that it's a unique identifier for each individual record. Because if you take a look at a record, if one of them has the same name, for example, like if you have two records named Bob, how do you know what's the difference between the two Bobs, right? So you need some sort of a unique identifier to signifies each individual record. And usually that's the ID. So you'll typically find an ID column that signifies the primary key. So once it is assigned a ID, that is its own unique identifier. So if it has an ID of 1 versus ID 2, you know that those are two different records. And it's typically the ID, but it doesn't have to be. So you can have those be like a unique email or a username, whatever it is. But just know that the primary key means it's a unique identifier. So you can look up the whole record with that single column. And then there's other ones here. There's not null, meaning that you have to have a value. You can't just leave it blank, for example. So if you have a not null on the email column, that means that you have to have an email for you to create this record. So that's what not null means. Unique is pretty self-explanatory. That's typically with usernames as well as emails. So if you have the unique with those columns, so that column needs a unique identifier, then it has to be a uniqueness with that email or the username. So you can't have two of the same records with the same emails or the same username. And then default is actually default values you can give it if they don't type in anything at all. And this could be anything you want depending on their data type, right? So you can give them like a default money value if you're dealing with a bank. So they'll have like $10 once they sign up or something like that. That could be a default value that you can put in. So those are the individual key terms that you'll be hearing throughout this lecture. So I'll send out what all of this is, and then you can put it inside of your notes. I just have a notes.sql file inside of a folder, so that's where I'm putting all of my notes here.
Can you say a little bit more about like MySQL and SQLite, and because like I've actually seen all these like in like skills for job postings and that, and it's confusing like what the difference is really.
Yeah, so there's actually a subtle difference between each of these. The main core of it is just SQL, so they mainly use SQL as their base of language. So as long as you know SQL, you can actually apply for any jobs that require any of these skills. These individual items here, those are just programs that uses SQL. So the way that you interact with them might be a little bit different, varying from SQLite to Postgres and MySQL, things like that. So the tool itself, it might be a little bit different.
Okay.
Yeah. Okay. And then here is another way to see all the data types. So again, a integer is just any whole numbers. If you have a float, that's also something too, but it's not as common. A varchar is just any type of character. So you can have a character or multiples of characters. They're just referred to as characters instead of strings. Booleans are true and false. There's dates, timestamps, and time. So typically you would see that here and there. And then text is just a bigger type of string. And that's, so typically you would use like varchar or string for like your name and username, and text for like a Facebook description or post. A few more other items to talk about is that we'll be doing a bit of CRUD. And you'll probably heard this term be used a lot. But CRUD is actually an acronym of what you'll be doing in almost every single one of your applications. And technically, you are already doing some of these items as well. So what CRUD stands for, it stands for create, read, update, and destroy. So typically in almost every single functioning website, you will be able to create something, read something, update, and destroy something. So if you think about it, Facebook, you're able to create Facebook, look at other people's posts, create posts, update posts, and destroy posts. Same with Twitters, with tweets, right? YouTube with videos, things like that. So essentially, you'll be performing all of these actions inside of your programs, inside of your applications. Even inside of your grocery stores, right? You're creating a grocery item, and then you're able to see all of those items displayed. And then later on, we'll be seeing how we can update and delete those items, or remove it from cart or update your cart, things like that. So that is what CRUD is those certain actions that you're able to do in a functional application. And these are SQL commands, and I'll just show you what they look like. We'll go into them a lot more. So essentially, with the SQL commands, with the type of tool that we're using, which is SQL Electron, it really doesn't matter if you do all capitalized or all lowercase. But I will typically write SQL commands as all capitalized because that's what the original language requires you to, and that's what some of the other tools will by default require you to do as well. So that's how you know that it's a SQL command if it's all capitalized like that. And there's certain SQL commands for each of the CRUD actions, right? So select is read, there's update and delete. Insert is actually our create, and you can also create other things as well. And the same with the constraints. So if you have a foreign key, uniqueness, not null, primary key, things like that, that will also be all uppercasing letter as well. So I'll send this out. Okay, so with this, technically you can run SQL almost anywhere as long as you have a tool to help you communicate and use SQL. Our tool, again, we're using PostgreSQL. So technically you could go inside of your terminal and type in, I'll do this so you don't have to. You can type in PostgreSQL, and that will take you inside of Postgres so you can play around inside of there. So you technically don't need the tools, but the tools that we're using, like SQL Electron, actually displays and formats all the data at much more better response. So that's why we're using it. I forgot how to quit. It's okay. So let's go ahead with SQL Electron. And we're actually going to be creating a few other things inside of there. So we'll be creating tables, databases, records, and all of that. Just note that the examples that we do here inside of this lecture won't work for Firefox or Microsoft Edge. And then also commenting doesn't work for Microsoft Access databases. So some of the tools and the Postgres that you're using, they may require you unlimited access to other things. So you should be careful which one you want. You want to go much more bigger scale. So occasionally you'll see me do a comment. A comment in SQL is just 2 dashes together and then space and then the comment itself. Like inside of the terminal, you can actually just highlight whatever you want and do command ? And that should also toggle on and off your commenting as well. So when you see me take notes, that's the syntax I will be using. If you don't have it up and running, or if some of the commands fail, don't worry about it too much because I'll be slacking out everything. But just pay attention to what I have on my screen because that one should work. So you can see here, you don't have it yet, but these are all the databases that I created over the year. And let's go ahead and create your own database. Again, I'll do it in here first, and then I'll put it inside of VS Code so you'll be able to see it better. So if you want to create a database, it's as easy as just saying the keyword create and then database, because those are the SQL command, and then the name of the database. Is it good to name your database as the same name as your application? So you're building a grocery store, it should be a grocery store database name. I'm going to name mine Dealership Summer 20. And then to go and execute this command, it will just be this green thing right here. So, any guesses of what this command actually does?
You got the database now.
Yeah, it creates a database itself. So as you can see here, it should update your sidebar to have the dealership here. So go ahead and click on that. That should take you inside of your dealership database. So this tab should say dealership 20. If you're using other programs, and this is for the other programs except for this one, you may have to connect to it manually. And that's what the /c command and then the database name that you want to connect to. Or I'll just say database name. So you might have to connect to it manually like that inside of other tools. But for this specific tool, we can just click on it and that connects it for us. And you should be inside of here now. So now let's go ahead and create individual types of tables inside of this database. So with this here, it's good to plan out what you have. That way you don't need to think about it too much and just go ahead and build it out. But I'm just going to use the one that's modeled inside of the lecture. So with this particular dealership, where I'm talking about a car dealership, I'm going to create a table of cars. And typically your table name is plural because you're not dealing with a single car, you're dealing with multiple cars, right? And I am going to do an opening and closing parentheses here because after you create a table, you should specify its columns data type, and any constraints that you need. So let me show you a few of them. For example, we need a primary key, and this has a data type of serial. And that's just a data type that gives you a unique identifier. So it increments every time you create it. And this is our primary key. And we also have the make of the car, which is varchar. And the thing about varchar is that you can specify how many characters you can limit the input of each of the make. I'm just gonna say 50. And then the constraint it has is not null. It's also the car has a model. And be careful when you're using model and Rails because model means something else in Rails. So you might have to change it to like car model so it doesn't conflict in Rails. And this one will also have 50 as a character model. Not null. And we'll do a few more. We'll do a year. And year is an integer. Not null. And then there's color with varchar of 25 characters. Also not null. And then we'll do two more. So we'll do mileage, integer, not null. And then finally, we'll do something a little bit different. We'll say that if it runs, it will be a Boolean. It'll be either true or false. And we'll do like a default value of true. I feel like I'm typing slower in this rather than VS Code. Let me see if this executes. If it does, then I'll slack it out. If it doesn't, then I'll fix it. Awesome. Okay.
Is there a max value to integer?
I don't think so. It's just whatever the biggest number that the computer can handle, I believe.
Okay.
So this is what I typed. I just put it in here so we can break it down even further. So essentially, we created a table of cars because we're in a database called dealership. It's a car dealership. And each of the cars has these individual columns, right? So it has the ID, make, model, year, color, and mileage and runs. So the ID itself, you need at least one column to have it be a primary key. And our ID is our primary key. Serial will have it be auto incrementing for it to be a unique identifier. And then the make and model, as well as color, they are either 50 characters or 25 characters that the person can type. The other thing is that we have mileage and year to be integers, and then runs to be a Boolean. And we have not null for all these ones, so we don't want those to be empty. And then the default value of this one is true. So that is what the create table will look like. So when you're creating a table, you would need to have these different columns, specify the column name, the data type that they have, and any constraints if they need. And I am going to comment this out.
Can I ask, like, when you do all this in this local host, like, where is it actually saving it?
It's saving it inside of Postgres.
Okay.
So if you open your Postgres, there should be a cylinder called dealership or whatever dealership you called it.
Okay.
Hey, Henry,
It-
the
Yes.
Boolean. When do we, since Boolean is default true, in what case do we use it for the dealership context?
This is just saying that if it runs, it's either true or false.
Okay,
Yeah, that's just a different data type.
thank you.
You're welcome. I would comment things out as I go if you are using SQL Electron, because it'll actually run everything inside of there, regardless of whether it executed it or not. So, okay. So that first command is just to, well, since I have it here, I'm just gonna delete it actually. So with this first command, it allows you to create tables. So this next one is actually allows you to have individual records. So to have an individual record, we need to do a insert, which is the create CRUD action. And we are specifying into, and we need to specify that we want to do this inside of the cars table, the cars table. And you can also specify what attributes you want to have be filled out. So I'm going to fill out the make, model, color, year, and mileage. And the order of these really doesn't matter. You can have them different order if you want to. It doesn't have to match up what you did inside of your database. But the order of the actual value does matter, or else you'll have like color be like Jeep and the make would be like yellow, things like that. So this next one is actually where order does matter. And that is the values here. Does anyone want to give me a car example or what car they're driving currently?
Go with Mercedes.
Sure. Mercedes. Yeah. Sweet. Model. Yeah.
C.
Is that really a model? Sure. Color.
C class. Silver.
Silver. Awesome. Year.
2016.
2016. A guesstimate of the mileage.
89.
89. Awesome.
1,000. Sorry. It's all right.
Nice. So go ahead and execute that. And it will give you a green go like that. So that's how you would have a individual car be inserted. Oh, I forgot I mentioned, but in SQL is one of those languages that require you to have a semicolon at the end. So make sure you have a semicolon at the end. It's just good practice. But inside of this program, if you have it or don't have it, it will still understand what you need. So this will give you a single car. And then to take a look at all the cars inside of the database, let me show you what command that is. And we'll be using this command a lot. So it'll be select, and you can select columns, like you can only select like the name or the color, things like that. But if you want everything, it will actually be this symbol here of the times, the button before the 8 if you press shift. And I want to say from cars. So from whatever table that you want to grab it at. So what we're saying here is that we want to see all of the columns from cars. as well as the records. So here you can see that there's only a table here, and it only has one row, ID, with the make, model, year, color, mileage, and that is the value there. And that's how you would see all of the records, is this symbol here. This is the symbol for everything or all. That's what that means there.
How come it's not showing on the left under tables?
This one here, these are databases.
No, but like in the dealership Sum 20, it shows like the tables icon, but shouldn't it show up there if we made it, created
Oh
a
no, it doesn't show there. That's just for stuff you can do with that.
I think it's under public.
Yeah.
Oh.
Yeah, maybe it's that one. But that's just more information about the table itself. You would have to actually run SQL for you to grab some of the information.
Okay.
So when you make a table, that means you have to memorize the order that you put things in?
No, that really doesn't matter. You just have to know what is inside of the table column. Because what we have here, that could be in any order. It's just whatever order you have it here, those have to match with these values here. That's the only
gotcha.
order does matter. But these can be any order.
But if I was going to insert some later on, and I accidentally put color in front of model and make somewhere else, then I'd be throwing it off, right?
Yeah, exactly.
So you'd probably want to like make a note of the way you ordered a table every time you create one?
Not entirely. So this one really doesn't matter. I can mix these up. So year and color, those are mixed up from the way I created it. So you just have to remember the table columns in their data.
Oh, and then it will always rearrange it from how you created it.
Yep, exactly. For this next part, I'm going to slack out this line of code. And this is just to create a bunch of cars for you to play around with. So essentially, this is what I sent out. It's the exact same thing that we did up here, but this is just you're doing multiple cars at once. Because you don't want to do this 10 times, right? So you can actually do a comma and then continue on with multiple values. You just have to end it with a final comma and then no comma at the end. So go ahead and have that be inside of your SQL Electron, and you can still have the select star from cars, because after it's executed this, it should then execute this here. There we go. And you can see all the records of the different cars that we have inside of our table here. So those are the two commands you'll be seeing and using the most of, is select and insert for when you are looking at certain columns and records, and then inserting is creating a bunch of records. Don't press this again, because then it'll do this again, and you'll have duplicate cars.
Oops, too late.
Yeah. I'll actually show you how to delete some cars too. Okay. I'll keep this in handy, but I'll comment it out because we need to see all of our tables here and there. So the really cool thing about this is that now you can be able to visualize your data inside of your database. So you can see all the cars and all the details for each of the cars. Occasionally, there's some jobs out there that are called data analytics or data analysis, where you have to get certain information from information like this, right? So your boss may be asking you to pull up all the cars that are under like 80,000 miles. And there's a way to do that. I'll show you shortly. And also pull all the cars that are 2000 and newer, right? So sometimes you don't want to pull in all of the cars. You might want to pull in a certain criteria for the cars. And that is where the keyword where comes in. So let's play around with this. So we can do select, which is selecting all the cars. But I don't want to show all of these columns. You can if you want to. You just have to do a star. But I only care about the make for now. Model, year, mileage. So let's say that my boss told me to pull up the car's make, model, year, mileage inside of their database. Afterwards, I'm going to say that this is from the cars table. And let's say that he wants all the cars that have a mileage less than 50,000, which is reasonable. So this is where the where comes in. So where is a keyword where you can specify a certain condition. And then with this, I can say that the cars.mileage is less than 50,000. And let me slack this out. So what this will give you is it will give you all of the cars, make, model, year, and mileage with the cars that have 50,000 or less mileage. And the only cars that have it is just these two cars of the Toyota and the Jaguar. And then I would give that information to whoever I need it to. So that's the where query. So you can specify a certain criteria. So it's just whatever the table name is, dot, column name, and then you can do anything with that if you need to. And then this goes into what if I want even more criteria, right? What if I want, instead of just less than 50,000, I'll have even more criteria with that. So there's the and or syntax. And the really cool thing about SQL is that it actually utilizes that a lot. And it's just the and or. So let's say that a different query, I'm just going to change it slightly, is the year is going to be 1999. And then in SQL, the equal sign actually does mean equality, which is a little bit different than every other programming language. So equal actually means equality here. And the car dot make equals Ford. And you can go and the mileage is less than 50,000 and the years, whatever. So you can chain your and commands even more if you need to. But we'll just stop with 2 for now. We'll go ahead and execute this. And this will give you all the records that matches this criteria here, right? Which is this Ford F-150 here. But you may be asking, what if the make is lowercase f, not uppercase? Let's play around with that. So if it's lowercase Ford instead of uppercase Ford, does it still pick up this car? In actuality, it doesn't. So there's no result found for that particular car. So casing does matter in this particular case. So you may have to have some sort of validations when you're looking for a certain criteria, but just note that these items need to be specified by capitalization and spelling. So that is the and syntax. And with the or syntax, is you can do one condition or the other. So it either matches something to the left, or it matches something to the right, or it matches something with both of them. Let me paste this here. So instead of and, I'm going to put or here just to show you what I mean. So I either get the cars with the year 1999 or the make of Ford. And you can see here it pulls in this car that we have with 1999 and this other one that has a Ford here. So that is the and or syntax that you would see. So and means that it has to have both of these, in order for it to be returned, or would mean either one of those or both of those conditions can be met.
Can you search with like an asterisk and search for part of the word, or including like just an F or whatever?
Yeah, you can actually do that as well. If you want to do part of a word, there's this one that I am going to show you right now. So I'm actually going to delete this here, and I'll still be pulling in the make, model, year, mileage. Or actually, I'll pull in all of the columns just to make it easier to look at. And with that, I can do like cars.make. And then if you, Mike, sorry, that was weird. Make. Okay, cars.make, I finally got it. And the keyword that you'll be using to be, if it matches a certain pattern, is this keyword like here. So like, and then a specific pattern. And I'll show you how the patterning works. So if I just say J, and then with this the percent sign, it actually will give you any of the patterns that starts with a J. So you have Jeep and Jaguar here. So there's a percentage that does it. If you do it like this, this will start with a J. If you do it on the other side, that ends with a J. And then let me actually show you the other operations as well. So again, this is inside of your notes. I am talking about this right here. So this is the pattern matching for a specific pattern. So we just did this one, which is just J%, which starts. So this is starting, ending in a specific pattern. Find values that have a specific word in the middle, in the second position, or at least 3 characters long in length, or find a word that starts with an A, ends in an O. So you can have different patterns like that. That's an excellent question.
Can you use more operators, like if you want something with 10 characters in length in the same format?
Yes, you can have the AND operator to be used with that as well.
Yeah.
That is a good point. Cool. Sweet. So that's the and, or, not, and like. There's actually another one, and it's kind of the opposite of the other two. So I can do actually not. So I can say where not in a certain condition. And this I don't know, cars dot year is not equal to 2000. And this will pull everything but this condition here that meets this condition. And I believe that's every car. So there's also the not that you can use with the where. So with the where, you can actually specify conditions. And if you have multiple conditions, you can do and or. Like matches a specific pattern. And then where not does the opposite, where you can grab all of them that doesn't include that specific pattern. So let me show you this. I'm going to delete this and uncomment this out. So if you take a look at the ordering of this, of how the cars are ordered, what patterns do you see? How are these cars ordered?
By ID first.
Correct. So from the looks of it, it looks like whatever ID it is, that's the ordering that it has. But if I create or update any of these cars, it actually would be the newest item or the bottomest version. So it's also in the order of whatever is last touch, meaning that it's last updated or created, and that would be towards the bottom. But that's not always the case, right? You might want to have it by make or model or even by years of the cars. And I'll show you how to do that. And that is still using the where operator, but you want to have a condition with that. So select every column from cars. And this is what the order by. So I can do order by. And I can say car.mileage, for example. I was just kidding. You don't need a where clause with this.
Would it be cars.mileage?
You are correct. It's looking for car, but we don't have any car there. There we go. Thank you for that. So by default, if you do this, the ordering, it does it by ascending alphanumeric order. So alphabetical order, and the lowest to highest number. So that's ascending order. But if you want descending order, you just have to specify it. So descending, there's a word for that, and that's just this word here. That will give you the descending order if you want it that way. Ascending, you can say ascending, or you can just take that away. It's by default ascending anyways. And I'll show you that with something numeric, with like mileage. And I'll also show you that with something alphabetical, like make, for example. So that is alphabetical. And it does matter the casing too. So casing does matter when you have it alphabetical. And that's the order by syntax there. Okay. Yeah, there we go.
Maybe you'll show us. Maybe it's in the notes, but are you able to do multiple levels of the ordering? Like first, maybe you want to alphabetize by make. So then it would be like all the Toyotas, but then it's alphabetized at another level, if that makes any sense.
Yeah, you would just do a and syntax here. I think that's how you do it. So let's say cars.make and then cars.year. So it does it with that level as well. Or not. Oh.
How would it decide which one to put if the year is higher than the make?
I think that's the error I'm hitting. But yeah, I think you would have to do it one at a time. So only order it by one column at a time.
Okay, awesome.
You might have to push it into like another array or something, or a place to store all those values, and order them again inside of another column. That might be another solution. Okay, but yeah, let me slack out everything that I did so far. Yeah. And let's go ahead and go into our first break. Let's come back at 7:10.
Henry, could you help me with the SQL?
Yes, let me find that command in the meantime. This might be. Where we left off was that we looked through a bunch of SQL commands, especially how to create a database as well as records, and to take a look at some of those records. And next thing that we are actually going to be doing other CRUD actions besides reading and creating. And this one is the update syntax. So with the update syntax, is really good that you have to have a where attached to it. Because if you don't have a where to it, you will actually update all of the records, right? And you don't want that. You don't want to update all of the records unless you really have to. So when you do this next command, make sure you have a where or some sort of a condition before you press enter. So keyword is to do an update. And then the table name, which is cars in our case. And what we are setting, so we are setting, let's say that one of our cars doesn't work anymore. We'll say runs is now false. And if I press enter right now or execute right now, will have all of these cars be that has true to be false, right? So that's why this next part where you really need to have a where clause. So where, let's say all of the Fords are broken down. So we'll do cars.make Ford. And I'll also be doing this command as well, so you can see that change be updated. So again, anytime that you're doing update, make sure you have a where conditional, or else it will update all of the cars with that. Syntax error near cars.
Your Ford is all capitalized.
Oh, yeah, let me do Ford.
I have a question.
Sure.
If you accidentally updated all of your records without using the where
Yeah.
prompt, could you undo it? But is there like simple like undo commands in SQL?
In this tool, no, but in other tools, yes. So other tools like in Rails, you're able to roll back the last command. And then other tools also has like a backup database. So it will back it up like every few hours or something like that. So you may go back to one of those backup databases.
So be careful then.
Yeah. So with the people's data, especially production level data, just be sure that you have it backed up, and also be careful what you're doing. And in rare cases, you may not want to update it directly like this. You may want to update it throughout the app instead of inside of the database directly. But yeah, that is the update. So update the name of the table and what you want to update. And the most important one is that which one are you updating? Okay. Now the other CRUD action is destroy, which is deleting a car. Again, you need to have a specific where clause for this to work. And with this specific where clause, if you don't have the where clause, it actually will delete all of your cars, right? In a production level environment, if you accidentally do that, that's really bad news, right? You have to get all the old information back somehow, or you could potentially lose your job too. So be careful when you're doing update and delete here, because you do need the where clause. Let's say I want to do delete. We had one too many forwards. I'll just do forward. And it's good to be specific more than anything, because if I just say delete all the cars with forward, that will delete all the forward cars, right? I may want to do that, but I may not. So you can even specify even more by having like only delete the F-150 or the year like that. But a better thing is that let's say that I have two of the same cars. I can just say by the unique identifier instead. That's actually a better thing to do. So instead of doing like make, model, or any of the columns, a good thing to do is just an ID, because that's their own unique identifier. So the ID equal to 4. And there's no going back from this. Once you delete it from the database, it's outside of the database and no longer there. So you could delete with any criteria, but I would recommend the unique identifier so you can get the specific one that you want to delete. The other thing is that you probably noticed that the forward here actually jumped all the way to the bottom. And that's why I was saying that the ordering goes by the most up-to-date will be at the bottom. So
does that mean there would never be an ID 4 now at this point?
4, ID of 4?
Yeah, so like if we added another car, it would just go to 9. It wouldn't go to 4.
Let's check that out. So let's do I'll copy the insert here. So we'll do another car. So let's go ahead and insert another car. And any suggestions of a make, model? If not, it will be Jeep Curve white. Future car. And this would be 100,000 miles. So yeah, so that's a logical question. If I were to add another car at this point, will it have the ID of the one that's missing, which is 4? Or would it have a completely new ID? And if we actually execute this, and then I am going to select all the cars, you can see that it does jump to 9. So there's no longer an ID of 4. So it goes to the next iteration, not to what is missing. That's a good question.
Can you force a value of 4?
Not with primary keys, no.
Okay.
Because primary keys should be a unique identifier, but yeah, you cannot. I think in other tools you may be able to, but
Okay.
For this specific one you shouldn't. And it's best practice you shouldn't too.
One other question.
Sure.
Does it matter if you use single quotes or double quotes?
Yes. For this tool you need to have double quotes. Wait, what have I been using for?
You've been using single.
Oh, just kidding. I think double quotes and single quotes work as well.
Okay.
Just for a sanity check, I'm going to change these to double quotes. Yeah, I think only single quotes works for this tool.
Okay, thank you.
Okay, so I'm going to take a look at all the cars again. And you can see that we have our new car that we created there. So I am going to show you other things that could be useful. So earlier during the lecture, I said that you can do like an and like this, right? Where you can have the where and you can have certain conditions. So the car year 1999 and the make of Ford and whatever you need. There's actually an easier way to do that. And I would do it this way if there's 2 conditions, but if there's more conditions like this, you may have to do it this way. And this is also good if you have multiple columns that you want to compare with. But if you want to have it be like the make of Ford and the make of Jeep, then there's a way to do that as well. So I'm actually going to reverse this a bit. So select all of the columns from cars again. We'll be doing that a lot today. But in this case, the where cars.make inside of the parameters I have in this parentheses. So let's say we'll do Jeep this time. We'll do, since there's more than one Jeep, and Toyota, since there's more than one Toyota. Again, spelling does matter and capitalization does matter. So this will grab all of the columns from the cars table, the make where it matches these 2 criteria. So you can have multiple types inside of this end clause here. So that brings in all the cars with Jeep and Toyota. So that's pretty useful if you're looking for a range of makes and models. But what if you want to have like a range of numbers? Because technically you can't do like cars.year in 1999 and all that, right? That really doesn't make sense, and it actually will give you some sort of a syntactical error. So you actually will be using a different thing here. So instead of using in, so let's say I want to do mileage, you would actually use between. So with between, you can set a numeric range with that. I'll just say between 100,000 and 300,000, sure. Yeah. So you can specify a range of numeric values with the between clause. So that's between and end. For this next part, it's a little bit of confusing of how we're using it, and that is the alias itself. So what you would do is let me actually show you this in here instead of inside of our program. is that typically you would do like select the column name, and then you can actually abbreviate it or do it as an alias with some sort of an alias name with the keyword as here. So if you have like a really long abbreviated name or like a really long column name, you can just have it abbreviated as this alias name here. So you can use that later on. And you can say like from cars in our case. The benefit of doing that is that later on when you reference it, you can actually reference it as that column name. So it will be like where the alias name is equal to like Ford or something like that. So let me give you a better example. So if I have a column name of make, I just have this as M. Instead of typing out make every time, I can just reference that as M. And I'll say that this is from cars. I can later on reference this where cars.m equals to Ford. So that's how aliasing should work. But there's actually something wrong with this here. And that is because if we actually run this, there's no cars.make here. So it should just be M. It actually doesn't run top to bottom like you think. So you think that it will do this first, and then this, and then this. It actually doesn't do it by top to bottom. It actually does it by order of execution. So with that, let me show you this table here. So it does the from first, and then the where, and then group by, having, select, order by, and limit. So technically, you're here with the where, and you're using M, and M hasn't been defined yet until later on. So technically, when you do aliasing, you actually have to think of it a little bit opposite and define the alias in the where instead of the select. So that's a little bit of backwards thinking and a bit. But I think you would rarely use that. So just know that that tool is there for your disposal. Okay. For this next part, we'll be talking about joins. And it'll be nice if I have a little tool. But yeah, let's go ahead and see relational databases. Because typically you won't work with one database, you actually will work with multiple databases here. And let's say that with this database, we have another table called parts, and that's associated with our cars database here. So let me see what is the best to do this. Yeah, let's go ahead and hop into Slack. And I'm actually going to Slack this part out. So it is a little bit of a typing thing. So I'll break down what this does, and I also will run it as well. So essentially, this first line here is creating another table, right? This creates another table called parts. And this is a relational table. So it has all of the columns that it needs, like name, description, serial number, if it's broken or not, right? So those are all the columns that the parts need. And the ID is the unique identifier for each of the parts. But then you have something like this, which is car ID. And essentially what this is actually a foreign key. If you go all the way up here, a foreign key, it signifies the relationship between two of the records together. So in this particular case, when I'm saying a car ID here, that's a reference to a specific car. So if you think about it in a real world, you have multiple car parts, right? And with specific car parts, it only goes to a certain car. So that is where we're specifying the car here is in this foreign key of the car ID. And typically it's usually the parent's name and underscore ID. So you can think of it as a parent to child relationship, like inheritance of what we learned yesterday. So the parent will be car and the child will be parts. But it doesn't work the same way in SQL as it does in Ruby. The other thing that we did, if you already executed it, is that I just created a bunch of parts for us to use, right? So there's hood, scope, spoilers, tints and tires, things like that. So that's what this second part of the code is to create a bunch of parts for us to take a look at. And let's go ahead and take a look at those parts. So if you want to take a look at all of the parts, you do select star from the table name, right? In this case, the table name is parts. So those are all of the cars. I mean, those are all the parts for the individual car. As you can see here, these are the parts that are associated with the specific type of car. So I wonder if we can do both of these tables at once. Maybe give me a sec to try this out. Okay, I can only do one select from each table at a time. So if you can see here, this lift kit belongs to the first car with the car ID that matches 1. This one is the car ID that matches 6, 5, and 8. So this specific part here is only for this specific car. And give me a sec to pull this up, which is this one here. So that part only belongs to this car here. And that's how association works inside of SQL. So you would have to have some sort of foreign key constraint that signifies that those parts belong to that car. And you'll be using that here and there. Okay. The next part is talking about joins, and joins at the very base of it. It's really confusing. So let me actually show you a picture that shows you it inside of a diagram, and then we'll try this out here and there. So here are the joins in SQL. So there's 4 types of joins. There's the inner join, left join, right join, and then full outer joins. So with the inner join, it returns records that have matching values in both data types. Left join is all the record from the left, right is all the records from the right table, and then the full outer join is all of the records, whether or not they're inside of the middle part or not. So those are typically what a join is, and those are just grabbing certain types of data. So let's play around with this idea a bit inside of our items here. Where's my thing? Here it is. So we'll do a couple of joins and then we'll see how that works. So I am going to do a inner join. And typically with joins, it follows the same exact pattern. So whatever joins that you're doing, it follows the same pattern. You just need to switch it for the keywords, right? And if you're doing outer, it'll be outer. If you're doing left, it's left. So I'm going to use some aliases. So it will be P for parts and C for cars. So I'm going to be having the part name as part name, and then P dot broken. And again, we need to specify P further down the line when we do this. And then we'll also do P dot serial number. C dot make and C dot model. Again, we need to specify what C and P are in this next line.
You spelled serial number wrong.
Oh my goodness. Thank you for that. Serial. I'm surprised I didn't spell serial the other way. So I'll do cars as C here. And then we'll do an inner join. Again, if you're doing different joins, you would just change that to whatever join you're using, like left join, outer join, things like that. For now, we're only doing an inner join or parts. And here is where we'll be doing our P. And then on P.CarID equals C.ID. Now, what this does is that it returns to you the part name, but in this case, we relabeled it as part name. You can do that with the as well. The broken as well as serial number, and then the car make and model. So you can grab both of the information from both of the two tables with a join. And you can specify the condition with the on where the car ID is equal to the C.ID. So there's only 4 parts, I believe, and those belong to 4 different cars. So these are the parts, and you can grab it like that. So joins are really good if you're trying to have multiple information from multiple tables. But yeah. Awesome. So with these next few items, I actually am going to do this in the other part, because you shouldn't ever do this on purpose. So let me copy this over here. Okay. And then with this, for this next command, is how you actually drop a database. Well, when we are saying drop, that means to delete everything inside of this database, as well as the tables, columns, rows, and all of its records. Again, I would never want to do this, especially if it's a live project, but I'll show you it anyways if you are curious. So keyword is drop, database, in the database name. Again, be 110% sure that you want to do this, because there's no going back from it at all. So just have that as your notes. Don't execute that. So in our case, if you want to do it for our particular case, replace this with our database name, which is cars. And you can do the same thing with tables as well. I'm sorry, ours is called dealership, not cars. The table is called cars. So if you want to drop a table, so that means that if you want to drop everything inside of that table, as well as all the records, columns, and all of that, then it'll be drop table and its name, table name. And everything that is referencing to that table will now be null, or it won't find it. For example, we have some parts here that reference some of the cars. Now those are no longer connected anymore, because there's no longer a car with the ID of 8, for example. So you can drop tables like that. If you want to alter the items, like if you want to alter anything inside of this table here, like let's say we want to add in another column this late in the game, it will be with this command here. So it'll be alter table. That's the keyword. And then you'll be using some sort of a table name. And for our example, it will be cars. And you can say add column name with the data type and any constraints. I'll just do cons. And if you don't have anything filled out for it, or if it doesn't have a default value, all of these will be null. So by default, it's null. So we can do that here if you all want. So if I want to do alter table, cars, we'll add, let's say interior color. So interior color, data type varchar, .50 characters. I'll just say not null. Well, actually, I'll just do this for now, and then I'll show you what's going on. So you can see here by default it's null. If I did not null there, I think it will give us an error. So it might have a default value, if anything. So that's how you would add a particular column if you need to later on in the game. But at the beginning, I would actually just plan out really well, right? So plan out your tables really well and make sure you have all of the columns that you need. Same with drop as well. If you want to drop a column, like let's say, never mind, I don't want the interior color anymore. Again, be 100% that you're sure you want to do this. It will be drop the column name, and you actually don't need this other information. So you only need to drop the column name. And then there's also the keyword column here too. So you can do like add, or I mean not add, drop column interior color. So you can manipulate the whole database structure itself. So there's no longer all of that there. Again, be sure you want to do that because it will delete all the data if it has any of the values. And then there's also ways you can change the data type. Like let's say that you want to change a particular data type of different varchars. That's alter table, the table name, and then alter column, the column name, and then the data type, the new data type that you want to have. And with the alter command, you can change the data type. You can also change the name of it, but there's a certain syntax for that. I don't have that on top of my head. And you can also change any database constraints as well. So you can work with that. And then there's also dates. You won't have to deal a lot with dates, but you'll be looking at them a lot. So for individual dates, timestamps, and years, they just have a different formatting of what the layout is for each of those. So you'll be seeing this in Rails. So Rails, every time that you create a record, it will create a ID for each of those records, and it will also create a timestamp. And it will create actually two timestamps. One for when the record was created at, and another timestamp of when it is updated at. And by default, both of those are the timestamp of when it's created at. So you'll deal with timestamps later on when we jump into Rails itself.
Are those the only available times, or can they do UTC milliseconds?
By default, Rails does timestamps, but if you need it in those other formats, then you would just specify the data types up above. But yeah, you can change them if you want to.
Okay.
Yeah. So I'm pretty sure there's one time with like time zones, without time zones, things like that too. So you can play around with time. The thing is that at the very beginning, when you're first learning to program, I would actually have, if you are having a column Like let's say if you have like let's say we are creating a table. Sorry, I'm going up and down. So if we are creating a table, brand new table, and we plan this out above here, and we'll do like a post. We'll do something more realistic. So we'll have an ID for the post, and then for each of these, for now, instead of the year or like the time that it's created, for example, instead of having it be like a time or anything like that, I will actually default it to string or varchar, just so you can have the basic items be done first. So for now, when you're dealing with anything with time in your database, have it be default string or very varchar. Then you don't have to like convert the numbers or change the numbers or what time zones or anything like that. But later on, change this to a timestamp or a time. Then you would have to figure out how to change it into different time zones and formatting with that. But yeah, just by default, do it as a string first and foremost. So any other questions about what we did so far? If you were to be good at a few things coming out of the class that will guarantee you job placement, one of the things is actually what we are learning here, which is SQL. Because there's always a need for a SQL developer, and a lot of big companies hire a bunch of SQL developers here too. Like Google for data analytics, they actually use SQLs and SQL queries. And all it is you will just go into people's websites and run some of these like commands, like give me all the cars that are certain mileage, and then give me all the cars from the years like 2005 to 2010, and then give me a data trend of what those cars and how well they're selling, things like that. So you might have to analyze those data with SQL as well. Okay, before I go into the first break, I actually want to summarize everything we've done so far, because I know it's a lot. When we're using SQL going forward, Rails actually takes care of it for us, but just note that it does do this in the background inside of Rails, so just know that. So again, SQL is just a query structural language, and it allows us to talk to our databases. In databases, it's just to collect and organize all of our data for us to have easy access to and to play around with. There's multiple tools for us to use in regards to SQL, but all of the main ones actually uses SQL as the main language. There's databases. Again, Postgres holds all of your databases. So inside of your Postgres, you'll eventually have a bunch of cylinders, a bunch of databases inside of your system. An individual database has a bunch of tables. These tables represents individual objects, right? Individual objects and what they hold with rows and columns. So with the table rows, the first row is all of the attributes that a car has or that object has. So ID, make, model, year, those are all of the columns or all of the attributes that object has. And then every row after that is the individual records. So individual values for each different instance of that object. A column is those columns I specified here. So it is just those attributes. And then our primary key is a very unique identifier. Typically, it's going to be ID. That is what separates and from each record from each other record. So a very unique identifier that you can reference to know individual records at a time. The foreign key is something that connects two relational objects together, two relational tables together. So typically inside of your parts, let me pull that up real quick, table, the car ID is actually a foreign key constraint. So for each individual part, it actually belongs to that particular car with a certain ID number. So that's what a foreign key is that it connects two records together with a specific column called a foreign key. Not null means that you can't have it blank. Unique means that you have to have a unique value, and default is a default value. And there's also other things that you can do as well. You can do like check, index, things like that as well. And the main thing you're doing inside of SQL is you're doing CRUD actions, right? You're able to create something, look at or read something, update, destroy, things like that. And there's certain commands that you would do. And we went through those commands during this lecture. And it really takes practice, and it's good to draw things out. So you can draw it out on paper. You can list out all of your items when you're planning out on paper and create some tables and columns. Or there's like good tools out there, like Lucid Charts is a good one, where you can create those schematics of databases and stuff like that. So you can use those tools to help you visualize it, because right now it's just like words and stuff, right? You actually need a visualization of what it is. So let me go into the homework assignment. Whoa, that is super small. Oh, sorry. Now it's too big. I'm not sure if this still is running anymore, but inside of the SQL Bolt practice, if you haven't used SQL Bolt before, I would actually go into this website and go through the tutorial. It's very similar of the other tutorial that we worked with, but this is an interactive tutorial, and it's just another way to teach you SQL. So like the first lesson, will take you into a database with a bunch of movies, and you're supposed to find a title of each film. I just gave you the first answer. And how you do that is you just need to write in different SQL commands. So that's how it would help you out, and to show you each individual commands there. And it does get harder and harder, but it's another way you can learn SQL and practice SQL. Okay, any other questions before we go on to our final break? So my plan for the rest of the night is, because we have a little bit of time, I'm going to leave the rest to have you work on your projects if you don't have that finished up. So after you come back from break, I will go ahead and put you all into your respective groups, and then you'll be working into your projects from then on out. So yeah.
Can I ask you a question about that, actually?
Sure.
Like when we turn it in, do you want it super detailed with like comments and that, or is it basically like, hey, this runs, your set?
So what we're looking for when we're grading is that we're first looking for if the basic objectives are finished. Like if you're able to add stuff, view the menu, things like that. So that's what we look for first, and then we look into the bonus objectives. Right now, we don't really require you to test your code or to document your code at all. But those are something that you could do to help you kind of work your way around stuff. So you're more than welcome to come out your code just to see how things run and everything too.
Okay.
Any other questions?
For turning it in, do you just want someone to zip it and then they all just turn it in individually?
Yes.
Okay.
And if you haven't already, go ahead and finish up the quiz if you haven't done the quiz, and the first week prep work assignments, like those quizzes for like the about me and things like that as well. Okay, so with that said, let's take a break. Let's come back at 8:10. So let's take a good break, come back at 8:10, and then I should have your breakout rooms done by then.